Alright, welcome back to the shop. It's a week later now, and as you can see, I've got the belts fitted now. So everything's put together on the planer. The electrician came yesterday and put me a new cable on, and you can see I've cobbled up the cables down below, tidied them up so everything's off the floor, it's tidy. And I've been running this. I was running this yesterday for a while, and I've been running it just for about 10 minutes or so. I've only just come in the workshop. It's probably about 5:15 now on Saturday afternoon. I think it's the 15th of March. But anyway, you can see now everything is built, put together. I've got new seals in the bearings. I've put the belts on. You can see the belt there. These belts themselves, these flat belts, they're leather faced and they're reinforced with fabric material on the outside. It'll be quite strong. It'll be interesting to see how they actually hold up. I'm not quite sure. We need to see, especially on the side, if they start fraying because of the movement from one pulley to the other. But you can see I've given it a good oiling up anyway, so it's okay, everything's all right. This pulley here on the left hand side is the cutting stroke, so that when the table's going backwards, the work will be bolted to the table and the cutting tool will be in the tool post here, and the work will pass under the tool and it will cut. On this side here is the return stroke, so you'll see the pulley at the top is bigger than that side, and the bottom pulley is smaller than that side. That's a bigger one. So we got a fast return and we've got a slow cutting stroke. Alright, what I'm going to do now, if that noise in the background is my diesel heater running. It's a bit chill in here, so I've just switched it on. Right, let's have a look. Let's have a look at our Newton Tesla drive. Let's turn that down and press the button and let's see what happens. There you go, it starts moving. I'm going to set that at 400. Maybe a little bit more than that, perhaps. There you go. You can see it. If I come stand in the front, you'll actually see the belt switching from side to side. See that then? They moved, both of them moved. They moved again. Yeah. That's now configured correctly how it should be, with the belts and pulleys overhead. The whole machine is designed for overhead drive. And if we have another look at this pulley here, we'll see how it just pushes across. This is a loose pulley. The outside one on both sides is a loose pulley. The inside one is fixed. So the inside pulleys are both fixed to the same shaft. The outside ones are free. So we got a fast and loose pulley. So now it's running loose, it's free, and now it's driving. Okay, let's just have a look on the other side. So you'll see the gear will go forward and then reverse. See, it goes reverse now. So you can see there again. And watch this. It's on the loose pulley now. There you are, it's on the fast pulley, it's driving. You only ever have one belt driving at any one time. The other one has to be on the loose pulley, like now. That's driving, it's coming forward, switch over, that's driving, that's on the loose pulley. And you can see, remember I said in the last video, we talked about the crowning on the pulley there. Can you see how well that's tracking? Beautiful, that is. That's nice. And you can hear the fastener going over the pulley here. And it's typical, that is on flat belt drives. Unless of course you've got the joint where they're scarfed and where they're stitched or glued. You wouldn't get any noise then. But I'm quite pleased with that, that's really good. This tool post here, this is known as a lantern tool post or an American tool post. It became popular probably in about middle of the 19th century. Obviously, it was an American design. Tool posts on shapers and planers in Britain were a very crude, robust affair. There was no adjustment for angles and things like that, or very little. When these came in, these were quite a novelty. They became very popular. You find most more modern shapers that were built probably in the last century had this type of tool post on. But the only thing with this tool post is it's very limited on the size tool I can actually put in here. The one on the Atlas is a little bit bigger, but it's not quite as wide as I want, and I'll just show you why. You can see this is the proper Atlas tool for this. That won't fit in the planer, and I want it to. But what I don't want to do is I don't want to cut this original lantern tool holder up. What I want to do is to make a new one. Now, interestingly, the dimensions of this on the inside of the clapper are the same as this on the inside of the clapper. So what I'm going to do is I'm going to make a tool post. I'm going to make a tool post that is unique just for these type of tools here. And these are too wide. That's a proper planer and shaper tool. You can see that there. And if you remember one of my earlier videos, I talked about the cutting edges at the back. So under heavy loading, what would happen is that would deflect away and wouldn't dig in. And so you'd get a good finish on your work. Well, that's a butt welded, high-speed steel, that's forged cutting tool. Only the end here is butt welded on, and the rest of it here is forged at the height. That'll be a really tough steel, that will. These are still made in England. You get these from a company called Rennie in Manchester. You might find some old ones on the internet. A company like Stag Major or whatever made them, but I've got some older ones here which are quite interesting. These are planer and shaper tools. That's unusual looking one there. That is a spring finishing tool. You would probably only have about maybe 1 or 2 thou depth of cut on that, and it was really a scraper, to be honest, and that would just polish the work as it passed over it. These tools here, they're all high carbon tool steel. They're not high speed steel. They were developed and made in the days before high speed steel came along, when steels were a lot softer, they were more wrought. High speed steel came along in response to increasing production needs and tougher steels. These here, these are modern ones. These are high speed steel butt welded. These are conventional lathe tools which you can use quite well on the lathe and on the shaper and the planer. And I would like to get or be able to put them in the tool post if I need to on the planer and the shaper. So that's what we're going to be making our tool post for. And if you look at this tool post here, our new one will be slightly wider on the slot. That's the only difference. I don't want to cut this one off because this is the original Atlas one. But if I can make it slightly wider on the slot, I can put the older tools in there, which is what I want to do. Now what we'll do, we'll find ourselves a piece of scrap steel, a decent size bit of steel, and we'll bolt it to this table, set it up, or clamp it, do what we need to do. A planer like this, a machine of this nature, means that you can't put a vise on in the conventional way like that. It would smash against the column. If this was an open-sided planer, in other words, it would just have one massive column here, and like a cantilever sticking out where it had the tool arm on it, you could have put a vise on, but why would you have a vise if, the vise is only a short stroke? So what you would need to do really is you've got to be able to fix your work and big pieces of work direct to this. And so we'll have a look at that in the future. But there you are, it's still running. It's quite nice. Everything's cool on it. There's no overheating, anything like that. And it's running quite well. I'm quite pleased with that. That's really good. You can see my trusty oil can down there. It's been doing some work, that has. I'm going to get some new oil for these gears and get some really heavy circulation oil, maybe a 460 or something like that. Don't want anything with any EP additives in it. EP stands for extreme pressure. I don't want any of them because with the old materials of construction, sometimes the EP additives can attack the metals, so you've got to be really careful with stuff like that. But anyway, there you go, that's our machine. It's running, it's working, and I am really pleased. Beautiful. There you go. Alright, thanks for watching.